Hi YouTube, Tim Uckert here. In this video, we're going to find the reference angle for the given angle. Now, the reference angle is the angle formed by the terminal side of the angle and the x-axis for whatever quadrant the terminal side of the angle ends in. So, for instance, let's draw this out to demonstrate what I mean here. So, let's say I have my y-axis here and my x-axis here. And let's say our angle goes into quadrant 2. So we have the angle here. Okay, some angle theta. What our reference angle is the angle between the terminal side here and the x-axis. And we might call this beta, right? So beta is our reference angle, theta is our actual angle. Okay, so for 23 degrees in this first problem here, well, our terminal side ends in quadrant 1, so the angle's maybe something like that. So this would be theta. Well, theta, our angle, is going to equal the reference angle beta. So our reference angle is going to be 23 degrees for quadrant 1, or for this particular problem. Okay, let's look at the second one. We want to find the reference angle for 101 degrees. Okay, so let's draw this out so we can think about where this is. So we got your x-axis here, your y-axis here, and the angle is going to end somewhere past 90 degrees, 10 degrees, 11 degrees past 90 degrees. So this is your regular angle. Let's call that theta. And then our reference angle here is beta. It's this angle here up from the x-axis here. So what is that? Well, in this particular case, if we take 180 degrees and subtract theta, so we do 180 degrees and we subtract theta, we'll get beta. Okay, so 180 degrees, we take off 101 degrees. What do we get? Well, we get 79 degrees as our reference angle. Okay, take a moment to take this in because I'm going to delete it and we'll move to problems 3 and 4. Okay, and while we're about ready to go over 3 and 4, you might want to pause the video and try these on your own. Also, smash that like button, please. That'll help this get out to more people. Okay, so let's look at problems 3 and 4. So we want to find the reference angle for 230 degrees. So again, I always like to draw these out. I think it helps best to take a look at that. And that line got thicker for some reason. I don't know what that. So we have that big x-axis there, and we have our y-axis. And we want to know, where does 230 go? So 180 is a straight angle, and if we go 50 degrees past it, we're at 230. So this big angle here is our theta. And then this smaller angle here, that's not going to be our reference angle. I don't know why I did that. This smaller angle here is going to be our beta. So in this case, to find the reference angle, we have to take this angle theta, and then we're going to subtract off this 180 degrees here. Okay, so if we so in this case, our reference angle is going to equal theta minus 180 degrees. So we're going to take 230 and we're going to subtract 180 and we're going to get 50 degrees. Okay, so that's our reference angle for problem 3. Let's look at problem 4. So we'll draw our y-axis, our x-axis here, and our angle is almost going full circle. It's just 8 degrees shy of full circle. So our theta is this angle here, and our reference angle is this small angle here. So in this case, our reference angle beta is going to equal 360 degrees minus theta. So it's going to equal 360 minus 352. So it's going to be 8 degrees. Okay. All right, take a moment to take that in because I'm going to delete it now. All right, and let's move down to problem 5. We're going to take a look at this one in radians. So again, I love to draw this out, and we'll draw it out and label in radians. So draw out our x-axis here, draw out our y-axis here, and then we've got 0 radians, pi over 2 radians at 90 degrees, 1 pi radian at 180 degrees, 3 pi over 2 at 270 degrees, and then we go around full circle, 2 pi radians. So where is 3 pi eighths radians? Well, 4 pi or 4 eighths pi radians would be pi over 2 if we simplified it, right? So 3 eighths doesn't quite get to pi over 2. So this is our regular angle, theta, which is equal in quadrant 1, equal to the reference angle beta. So our reference angle here is 3/8 pi radians, or 3 pi over 8 radians. Okay, let's move to the next one. All right, so this one we're going to find the reference angle for 5 pi over 6 radians. So if we draw out our x-axis, draw out our y-axis, then we have 0 radians, pi over 2 radians here, pi radians here, 3 pi over 2 here, and then full circle will be 2 pi. So where's 5 pi over 6? Well, that's slightly less than 6 pi over 6, which would be 1 pi. So it's slightly less than that. So our theta, our regular angle, theta, is 5 pi over 6 radians. And we want to find this small angle here, which is beta. So we're going to do 180, or pi, in this case 6 pi over 6, minus 5 pi over 6, which is just going to give us 1 pi over 6 radians for that one. Okay, take a snapshot of that, and let's move to the next one. Okay, so problem 7. So we are looking at 7 pi over 5 radians. So we'll draw out our x-axis here, draw out our y-axis here. Not a very good y-axis, but so we, again, 0 radians, pi over 2 radians, 1 pi radian, 3 pi over 2 radians, and then we're back to 2 pi back here. So where is 7 pi over 5? Well, if I multiplied 2 by 2.5, I would get 5, and then I would have to multiply the top by 2.5, and that would give me 7.5. So we're close, but we're not quite to 3 pi halves. Okay, yeah. So think of that. If I divided both by 2.5, I would get, well, what's 7 divided by 2.5? Let's just do it quick. Just check. So 25 goes into 70 twice, and then we get 50, and then we're left with 20. Bring down another 0, add a decimal up here. And so it's like 2.8. 2.8 half. So it's very close here, but it's still in quadrant 3. So we have theta here. Our beta is here. Our reference angle is here. So what we're going to do is we're going to take this angle here and subtract pi from it. So we do 7 pi over 5. And 1 pi written with the denominator of 5 would be 5 pi over 5. And we're going to get 2 pi over 5 as our reference angle in radians. Okay, take a moment to take that in, and we'll do one more. Okay, so let's look at this last one here. We want to find the reference angle for 7 pi fourths radians. So draw it out as always. So we have our x-axis, our y-axis here. We start at 0 radians. We go to pi over 2 radians here. 1 pi radian here. 3 pi over 2 here, and then 2 pi here. Okay, and 7 pi over 4. Well, 6 pi over 4 would be the same as 3 pi over 2. So we're past that, but we're not a full 2 pi. 2 pi would be 8 pi over 4. So we're into quadrant 4, somewhere in here. And our regular angle, the 7 pi over 4, is that. And our reference angle is this. So we're going to take 2 pi and subtract this angle to find our reference angle. So we're going to do 2 pi with a denominator of 4, so 8 pi over 4 minus 7 pi over 4, and we'll get our reference angle of pi fourths radians. Hopefully this video was helpful to you. If it was, please like and subscribe. Also, for teachers or anyone interested in some worksheets, I have free and paid stuff for my Teacher Pay Teacher store. I'll leave a link to that in the description, as well as a link to my website. I hope to see you in the next video. Have a great day.